Hey everyone, welcome back to another lesson. Today we're going to talk about the range of functions. And for today is how do we find the range of functions. Homework number 3, the one that corresponds with this lesson, is in our open source textbook, page 36, numbers 31 to 37 odd. So that's 31, 33, 35, 37, and page 37, numbers 57, as well as 61C. 61C, by the way, that is a continuation of the problem from homework number 2. So I told you guys to ignore range, but today, since we're talking about range, I want to have you guys complete that problem. Okay. With that being said, let me get to the do now. So here it says the graph below gives the weight of a certain person as a function of age. Describe in words how this person's weight has varied over time. What do you think happened when this person was 30 years old? Okay, so for the description, I'll do it right here in this video. But for our synchronous Zoom session, I'm going to ask you guys, what do you think happened when this person was 30 years old? So come up with something. All right, for the description, here we go. So it seems like the person started off at like 8 pounds as a baby and then gradually increased in weight until they were about 20. At 20, the weight still increases, but it's just at a slower rate. And then up until they're 30, still increases. Then at 30, which is the age in question here in the do now, the weight drastically decreases. Okay, and then it tapers off at about 125, and then it starts increasing again right when they're like 35-ish, and then it starts another slope right at around 36, 37. Still increases, but just at a slower rate. Okay. All right. But yeah, that's it for the do now. So as a follow-up question, I want you to think about range. So the range of this function, the range of this person's weight will be like 8 pounds up to about 200 pounds. Okay. So the range is the set of all possible output values. Okay. So the set of all y values, in other words. I'll get to the exact definition in a sec, but let me just give you an overview of what we're going to talk about today. Okay, so we're briefly going to talk about that definition of range, and then we're going to go to an example, and then we're going to jump to a different topic. So since that's a short definition, I'm going to jump to another topic. Today we'll also talk about power functions and the definition of a one-to-one function. Okay, and then from there we'll get to our worksheet. Okay. All right. So for your definition, here it is. The range of a function f is a set of all possible values of f of x as x varies throughout the domain. And by the way, just to keep the video concise, I'm going to be speeding through the definition, so I won't pause the video. So if you, for you to copy the definition, please pause the video on your own. Yeah, so again, I'm just doing that to save time. I mean, I'll keep this slide here, actually the definition here, for now, just because the slide is pretty small. But yeah, let me jump to the example. Okay, so again, if you need to copy that definition, please pause video. All of you should be copying it. It's just some of you might need more time, less time, right? Okay, so use the pause button to your advantage. All right, anyhow, the example, use a graph calculator to draw the graph of f of x equals square root of 4 minus x squared and express the domain and range of the function in integral notation. Okay, so let me jump to the graphing calculator. So here I have a free TI-84 emulator. Okay, so I'm gonna just type that function in. So square root of 4 minus close parentheses. I'm gonna do zoom standard window. Oh, whoops, what's wrong here? Square root of 4. Oh, sorry, that should be a minus sign. That should work now. Okay, so as you can see, right, it's a semicircle. Okay, now if I zoom in and do Yeah, so these values here, the interval on the x-axis is going by ones, right? So here's 1, and then here's 2. So we can see that the domain is going to be -2 to 2, and the range is going to be 0 to 2 inclusive. So semicircle, right, -2 to 2, and then 0 to 2. Okay. Let me get to the actual solution to show you guys. Okay. All right, here we are. So here is the actual solution in interval notation, right? Domain is -2 to 2 inclusive, and the range is 0 to 2 inclusive. Okay. All right, from there, I'm going to move on to the next definition. Okay, so we're going to briefly talk about power functions. So this question here is describe how the value of the exponent n affects the shape of the following graphs. And I know this is kind of a tangent because it doesn't really have to do with the range of functions, but we are going to have to, use concepts discussed like right now for range, right? So I mean, these are graphs in which we can see that the range is different for each graph, right? But yeah, I'm going to also relate it to power functions. Okay. But anyway, to answer the question directly, the value of the exponent n affects the shape based on the parity. Parity, that's just a fancy word for odd or even, right? So x squared and x to the fourth, those are even functions. And then here you have odd functions, right? X to the third, x to the fifth, right? So anytime you have x to an even exponent, it's going to look like a parabola, right? It's going to be parabolic. And then anytime you have x to an odd power, it's going to look like a cubic function, right? Like an S curved shape. You could also talk about the symmetry here. So x squared and x to the fourth are symmetric about the y-axis, and x cubed and x to the fifth, those graphs are symmetric about the origin. Okay, another way to see the symmetry about the origin is you can reflect it over the x-axis and the y-axis, and you'll get the same thing. Okay, so if you split this in half, reflect over x and then y, you get the same thing. And the same thing for here, right? Reflect over x and then y, right? Okay, let me show you the actual answer though that I wrote. So the functions where the exponent is even look parabolic and the others go up in a curving way from left to right. X squared and x to the fourth are symmetric about the y-axis, right? These graphs. And x to the third and x to the fifth are symmetric about the origin. Okay. Next, I'm going to talk about one-to-one functions. Okay, so I know there's a lot of notation here, but this is actually a pretty simple idea. I'll give you the analogy after I read the definition. Okay. So here it says a function with domain A is called a one-to-one function if no two elements of A have the same image. Image, that's just a fancy word for y value. Okay. That is f of x1 is not equal to f of x2 whenever x1 and x2 are not the same. Right? An equivalent way of writing the condition for a one-to-one function is if f of x1 equals f of x2, then x1 equals x2. Okay. All right. So the analogy I want you to think about when thinking about one-to-one functions is OSIS numbers. Okay, so all of you as Bronstein students have a unique OSIS number. Okay, so for you and think of a friend, right? For you and your friend, both of you have a unique and individual OSIS number, right? There's no other person at Bronx Science or New York City, or actually, I guess you can say the world, right? Assuming that OSIS numbers are unique. There's no other person in the world that has the same OSIS number as you, because that OSIS number identifies you, right? So to relate this to our definition, right, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. Okay, so if you see people as x1 is not and x2, right, or Bronstein students, right? So whenever you have two different Bronstein students, you are going to have two different OSIS numbers. Okay. Okay, I'll say that again. So whenever you have two different Bronstein students, you're going to have two different OSIS numbers. Okay. And to relate this to the second bullet point, if f of x1 equals f of x2, then x1 equals x2. So this is just saying that if you have an OSIS number that matches itself, right? So think of your OSIS number, and you have another OSIS number. You want to identify whose OSIS number this is. If this is a one-to-one function, then then we can conclude that that student is the same person, right? So if you have two of the same OSIS numbers, then you are actually talking about the same person, right? X1 is actually equal to X2. Okay, so whenever you think of one-to-one functions, think of ID numbers or OSIS numbers, right? Okay. With that being said, let me get to the next part. I think it's the worksheet. Yeah, just the worksheet, and then we'll be done for today. Okay. All right, so as always, I'm going to post this on Google Classroom, so please try this on your own, and then I'll go over the solutions here in this video. All right, so number one, you have three different graphs, x squared, x to the third, and square root of x, and our job is to define, or not define, specify the domain and range in set builder and interval notation. All right, so the domain here is all real numbers, right? If you think about it, you can plug in any number into a parabola and it'll come out with a number, right? So there will be no x value that will produce an undefined value. Okay, so any value is okay. The range is different, right? So that would be anything above 0, inclusive of 0. So y is such that y is greater than or equal to 0. And then for interval notation, it's bracket 0 to infinity. Okay, that's part A. And then for part B, we have x cubed. And domain, you can plug in anything, right? So any number will work, right? There's no number that will produce an undefined value. Same thing for the range, right? You can actually see on the graph here, right? It extends to positive and negative infinity. You can attain any x or y value. Or I should say y value, but any x or y value is possible here. Okay, so the domain and the range are actually the same. It's just any real number. Square root of x is our final part. Okay, so here we have the domain being 0 to infinity. Right, and that makes sense, right? Because you can't take the square root of a negative number without using imaginary numbers, right? So x such that x is greater than or equal to 0. Okay, so 0 to infinity. And then the range is also 0 to infinity. Okay, so anything above 0, inclusive of 0, right, is attainable. Okay, so in this case, domain and range are also the same. Okay, so for both these graphs, domain and range match, right? That's not always the case. So next, we'll move on to question 2. So this one is the same, right? Same instructions, I mean, but this time we don't have graphs. You could technically use a graph here, so you can use a graph calculator, but for part A at least, it's not that bad, right? So here it's 6 minus 3x. That's a line, right? For a line, you can plug in anything. Okay, so the domain is all real numbers. Same thing for the range, right? So all real numbers are attainable by this line. All right, actually, let me graph this. So on the homework tonight, you'll see that you'll make a lot of use. You're going to have to analyze the graphs. Okay, so just to give you guys practice. Here. Okay, so let me graph 6 minus 3x. Let me change that window, zoom standard. All right, so as you can see, it's downward sloping line. But yeah, you can plug in anything for x, and all y values are attainable, right? The line goes on forever, okay? All right, back to the lesson. All right, part B, this is a parabola, right? X squared minus 4. So this is a parabola that's been shifted down 4 units. Okay, so all real numbers are okay for the domain, and for the range, it's -4 and above, inclusive of -4. This is the interval notation here, so negative infinity to infinity, and then for the range, it's -4 to infinity, inclusive of -4. Let me graph that too, so you get a visual. Okay, so here we have x squared minus 4. And as you'll see, right, it just it's vertically translated down 4 units from x squared, and -4 up and above are the attainable values for your range. All right, last but not least, part C. So here we have absolute value of x minus x. Okay, so I know this is confusing because this is unfamiliar, but it's actually not too bad. If you think about it, you can plug in anything, right? So there will be no x value that will produce an undefined value. So the domain is all real numbers. For the range, this one's a little trickier, but for this, I'll just plug in some numbers. So I'm going to plug in a negative number, 0, as well as a positive number. Right, so for a negative number, right, let's say you plug in -5. Right, so let me write this here. Oh, press that. Okay, so here we have g of -5, let's say, right, equals absolute value of -5 minus -5. Right, so this be 5, right? Absolute value of -5 is 5, and then you have plus 5, this is 10. Okay, so actually you'll see that negative values in this function produce a positive value. And we have, let's try out 0. Value 0 minus 0, and that'll just be 0. Next we have g of 5, let's say. G of 5 equals absolute value 5 minus 5. That'll be also 0. And for any positive value, you'll see that it's going to be equal to 0, right? Because it's going to be just the number minus itself, right? But for negative values, it's different because you're subtracting the negative value, which will lead to a sum, right? So that'll be 5 plus 5. But just to extend that thinking, so like let's say you plug in -10, that so absolute value of -10 minus -10, that's 10 plus 10, which is 20. Okay, so you can actually attain any value above 0. Okay, so the range here is going to be 0 to an infinity, inclusive of 0. Okay, and just to emphasize that point, if you don't believe me, just graph it, right? It's always an easy way to come up with the range. So for my absolute value sign, I'm going to need go to math and then number, and then the first option is ABS, which stands for absolute value, and x minus x. Okay, and graph, you'll see that, yeah, so it doesn't show up here, or I mean, it overlaps with the x-axis, but this graph is for negative values, it's actually positive, right? And then starting at 0, it'll just be equal to 0. Okay, so it's like this, and then that. And yeah, as you can see, right, the range is going to be 0 to infinity, inclusive of 0. All right. All right, last but not least, just a quick summary of today's lesson. So if you have been falling asleep throughout this video, that's okay. I mean, make sure you go back and watch the video again. But if you don't remember anything else besides this, that'll be decent. Okay, so it just says the domain of a function consists of the values on the x-axis, and the range of a function consists of the values on the y-axis. Okay, so when you hear domain, think of x-axis. When you hear of range, think of y-axis. Okay, and I believe that's all I wanted to say for today. Yeah, just remember to complete your homework and submit it by tomorrow night. Okay, that's it for today. See you guys next time.